Hello everyone. Welcome to all. Today we are going to study about the N-type and P-type semiconductor. Um, Generally, the semiconductors are classified the internal semiconductor and external semiconductor. Depending upon the type of impurity is added, the external semiconductor are classified as N-type semiconductor and P-type semiconductor. Now we are going to study about the N-type semiconductor. When we add a pentavalent impurity to the pure semiconductor, we can get a N-type semiconductor. The N-type semiconductor fifth group element is added as a doping element. Impurity added provides extra electrons and is known as a donor atom. Like fifth group elements are pentavalent impurity like phosphor, arsenic, bismuth, etc. We are adding the element to the pure semiconductor. We are getting for the N-type semiconductor. In the N-type semiconductor, the majority carriers are only the electrons. Where a small amount of pentavalent impurity is added to the pure semiconductor, we will get for the N-type semiconductor. The addition of pentavalent impurity provides a large number of the electrons in the semiconductor crystal. Such impurities which produces the N-type semiconductors are known as donor impurities. I told you because they donate or provide free electron to the semiconductor. In the N-type semiconductor, the majority carriers move from lower level potential to higher level potential. And also, the holes are minority carriers. In the N-type semiconductor, the holes are minority carrier and the majority carriers are electrons. So that the electron density is much greater than the hole density. The Fermi level's energy lies between the donor energy level and the conduction band. The donor energy level is close to the conduction band and away from the valence band in N-type semiconductor. Arsenic atom has a 5 valence electron. For example, the arsenic atom has a 5 valence electron. The fifth electron is superfluous, becomes the free electron and enter into the conduction band. Therefore, the pentavalent impurity donates one electron and becomes positive donor ion. So that ion is called as the donor. Pentavalent impurity donor is known as a donor. And next one is P-type semiconductor. Where a small amount of a trivial impurity is added to a pure semiconductor, it is called as P-type semiconductor. The addition of trivial impurity provides a large number of holes in the semiconductor. Like indium is an example. Such an impurity which produce P-type semiconductor are known as accepted impurities because the holes created can be accept the electron. In P-type semiconductor, gallium atom has 3 valence electron. It makes the covalent bond with adjacent the 3 electron of silicon atom. There is a deficiency of one covalent bond and create a hole. Therefore, the trivalent impurity accepts one electron and becomes the negative acceptor ion. So the trivalent impurity is known as the acceptor. In this type of P-type semiconductor, the third group element is added as a doping element. It means the trivalent impurity like aluminum, gallium, indium, etc. Here, electrons are minority carriers and holes are majority carriers. The impurities added to the pure semiconductor, it creates the vacancy of electron holes called as acceptor atom. In addition to this, some of the covalent bonds break due to the temperature and electron hole pairs generated. See, this is a P and N type semiconductor. Here, this diagrams indicate that the acceptor ion and donor ion. In P is the left side, the P type semiconductor is there, and right side N type semiconductor is there. In left side, what is there? The acceptor ions are there, and right side N type material donor ions are there. In P type, some of the minority electrons are there, and then the majority holes also there. So the P type having more number of holes are there, and less number of minority electrons are there. In N-type semiconductor, donor ion is indicated there plus, and minority holes also there. The majority of electrons are present in the N-type material.